Hi, I'm Tony Kramer, Product Specialist with RDO Equipment Company. Welcome to the Agriculture Technology Podcast on RDO Equipment Company's YouTube channel.
Every day, there are phenomenal advancements being made in the field of agriculture technology. RDO Equipment Company is a leader in agriculture equipment and precision agriculture technology and is here with industry experts bringing the latest news and information from RDO and John Deere. Thanks for joining us on the Agriculture Technology Podcast.
Welcome back to another episode of the podcast. This is episode number 92, and today we are going to be talking about precision agriculture and also a little bit on precision ag in the cotton industry. Before we dive into the show, please take a moment to subscribe to this podcast if you haven't already. You can subscribe to the show on many different podcasting apps that we're streaming this to. It's on Apple's podcasting app. We got it on Stitcher, Overcast, SoundCloud, as well as many others. While you're out there, drop us a review. We'd really love to hear what you think about the show. Lastly, make sure to follow RDO Equipment Company on Facebook, Twitter, Instagram, and catch all of our latest videos on YouTube. You can also follow me on Twitter at RDO Tony K. Now with that, let's get back to the show. I am really excited to welcome Jason Ward, who is an assistant professor at North Carolina State University. Thanks for joining us on the show today, Jason. To get started, I'd really like to hear a little bit more about you and your background and how you got involved in what you're doing today.
Hey, thanks so much for the opportunity to get to share a little bit of a different take on some precision ag. So actually, I grew up in Kentucky, which is not a cotton-producing state. So it's kind of interesting how I found myself working in precision ag in cotton production. So I did my bachelor's and master's there at Kentucky, and took a few years and worked for the USDA ARS in Auburn, Alabama for about 4 years. And then found my way to Mississippi State University, where I did my PhD work while I was working full-time for Extension there. After that, I joined AGCO for just over a year, and then find myself here at NC State University leading a group I call the Advanced Ag Lab, where we get to do some really fun things, everything from field logistics to UAV work, including cotton precision ag.
You definitely have a very extensive background and kind of career path when it comes to education and agriculture and specifically precision ag and what you're doing. I just want to dive into it right away. Let's just talk about precision ag to begin with, and then we'll talk a little bit about what you're doing in cotton production. So precision agriculture, what is it? What is the true definition of precision agriculture?
I think if you ask 100 practitioners, you would get 100 different answers to this question. But I really think that the way my lab and my team defines precision ag is that it's not a technology, it's a technology-enabled methodology. And I think that's kind of the key difference in how we approach it. So traditionally, we used to think of precision ag as terminals in the tractor and the CAN bus and writing prescriptions and doing as-applied files. And don't get me wrong, those are all still very much precision agriculture. But I think that environment has grown and changed so much to say that if that's the only precision ag that you're doing, you're actually missing out on a much broader scale that's allowing you to make better decisions on finer and finer management areas so that you can really increase your input, manage your inputs, get your output where it needs to be, and hopefully make good decisions that, impact your bottom line positively and maybe can reduce some environmental impact.
That is really a unique perspective and a different way of looking at it, because I too, coming from the equipment industry here with RDO Equipment Company, there are a lot of people that look at precision agriculture as components, the hardware, that you're using precision agriculture if you have a John Deere display and receiver, but the way you explained it there is it's a practice that you adopt. It really makes a guy think about it differently.
Yeah, it's a way of thinking. It's how do I approach this particular management problem that I'm trying to go after. It's breaking down what data do I need to make this decision rather than shooting from the hip or doing it the way my daddy and his grandfather have done it. And so that takes quite a bit of challenge because you need to get comfortable with a completely different set of skills. So we're asking that farmer or that consultant or service provider to do everything that previous generations of farmers have done in terms of being able to mechanically manage equipment and to manage people and logistics. But now we're asking you to be able to process data and to draw actionable insights from it. So it's a whole different tool set. And the thing is, we can't leave behind the ag. Even when we make it precision or digital ag, it still very much has to be the ag, and it has to work for our production system. I think getting in that mindset is a bit of a challenge.
I would agree with that, and I really do like the way that we have to shift what it is we're thinking about and how we're adopting this and utilizing precision ag from a holistic approach. Precision ag, whether it's the hardware you're utilizing or it's the mindset that we're in, down there at NC State, you guys are doing a lot of different research and everything. Why don't you talk to us a little bit about some of the research projects related to precision agriculture?
Sure. Probably one we're probably gaining the most interest in right now is that we're actually developing techniques to be able to detect crop damage, physical crop damage, after, let's say, a severe weather event, or maybe after there's been some kind of extensive wildlife damage, or even some kind of an insect issue. But really, the weather piece is what drove it home for us. Here in North Carolina, harvest season is hurricane season. And so we find producers in a situation where after a year's worth of labor and diesel and inputs and seed and all the things that went into making that crop, that a severe weather event comes along and can, basically steal it out from underneath them. So we really want to create tools that allow them to be able to assess the amount and severity of the damage and to be able to do it quickly. And we want that for producers. We also want that for insurance agencies to be able to understand what's on the line for them. We also want that for disaster declarations. The more accurately and the faster we can describe that crop damage, the faster additional resources may be able to come open at the state and federal level to help these communities start recovering faster. So using, in this case, UAVs to create these algorithms that can detect damage from color imagery is where we're starting, but we think that we can eventually extend this out to even manned aircraft or, I doubt we'll get to the point to be able to use satellite, but we really think that UAV and manned aircraft is what's going to give us the fastest ability to detect that damage in that severe weather environment.
I like it. I think that there's last year, speaking specifically from the region that we're in up here, kind of the Red River Valley, Minnesota, North Dakota, we had some pretty late season severe hail damage. And I think if you guys can nail down something for crop damage assessment, it would be one heck of an awesome tool to have in this industry.
Yeah, we're really excited about it. I've got a postdoc who has just done some fantastic work with some deep learning, using some artificial intelligence tools to see what we can extract from just simple RGB color imagery. Now, we can go further with maybe some of these, vegetative indices or multispectral imagery, but we just thought, let's get everything we can from a simple color picture first and then figure out what our gaps are.
Beyond the crop damage and what you guys are doing with that at NC State, are there any other research projects that you're working on today?
Yeah, absolutely. So many of the crops in the Southeast or in Southern ag in general are traditionally a little bit underserved when it comes to technology. And so, for example, I've done some work with peanut growers. Right now there's currently not a really good way to measure peanut yield. So one of the most foundational precision ag tools, the yield map, isn't available to those producers. I don't know that we'll ever find a perfect solution for them to map yield, but what we can do is map the machines that are pulling the combines, and maybe if there's something we can measure about the machine or the combine settings or combine performance that can give us some insight about the yield of that crop, then maybe we can find a good proxy. Just because that stream of peanuts are coming up out of the ground, they're dusty, there's rocks and sticks and everything else going up through when it's first got harvested in the field. So it can be kind of a challenging environment. So we're just trying to see if there's things that we can measure about that machine that can make that process more efficient, and maybe kind of use those field efficiencies a little bit better. But also, is there some kind of a proxy we can find that's going to equate to yield for these kind of underserved crops?
Yeah, we always, when we think agriculture and we think precision ag, a lot of us, whether we're trying to or not, we get stuck on the typical corn and soybeans. Maybe some wheat goes in there, but there's a lot more to agriculture than just kind of our typical corn and soybean crops. Even speaking here in the Red River Valley with the sugar beet crop that we utilize, we're starting to get the opportunity to run more of this precision agriculture or utilize this precision agriculture practice within these specialty crops. So to hear that NC State is working on kind of improving the spectrum of crops that we're focused on in precision ag, it's really awesome to hear, because as well as I do, agriculture is so much bigger than just corn and soybeans.
We really, especially in North Carolina, we've got so much diversity in crop production. We have all the big players. We've got corn and wheat and soybeans. We've got cotton. We've got peanuts, and we've got a huge amount of vegetable crops. Sweet potatoes. So we are definitely a truly diverse state. And that's one of the things that excited me about being able to work here at NC State, was trying to find the right tools and technologies that can help those producers in those specialty crops as well as the mainline crops.
Now, keeping in line with those specialty crops and what you are doing, Jason, the cotton production with and as it relates to precision agriculture, let's dive into that a little bit deeper and just talk about what's out there and what you guys are working on to kind of advance precision agriculture with cotton. So the first question I got is, I'm not a cotton guy, so let's talk to a little bit about what precision ag technologies are out there today that can be utilized in cotton production.
Yeah, sure. And let's just kind of take it right through the production cycle, right? So if we look at planting, when cotton emerges, it's not a super vigorous plant when it emerges from the ground. And so there's a lot of replant decision that has to be made. So we're utilizing some tools now, which haven't been used in other crops, but as far as moving some of this early season UAV imagery or other ways to detect emergence and vigor are being applied right now to help look at that replant decision. So kind of right now, the standard definition is if you see gaps greater than 3 feet on 50% of your field, then you need to replant. But there's not a whole lot of people that are going out there and specifically measuring those gaps. There's a lot of windshield decisions being made, right? So if you can see the gaps if you're going at 50 versus can you see the gaps if you're going at 30, right? So there's kind of some decisions being made in a way that's not super analytical. So we're trying to introduce some tools that can help make that more consistent and can hopefully pay some returns in preventing replants that didn't need to happen and making sure we find the replants that do need to happen. If we look at spraying, cotton's an interesting crop in that we actually have to apply, if needed, a plant growth regulator to it. Because if you look at a cotton picker, there's only a certain height of plant that can really go through that cotton picker. So we need to keep it underneath that level. And one of the tools that we use for that is plant growth regulators. So we can look at ways to variable rate that PGR by using something that's pretty common, like a green seeker. So we can actually connect green seeker reflectance to rank plant growth, and that gives us a pretty good correlation to aggressive plant height to try to do some variable rate work in the plant growth regulators. My colleagues, Dr. Gary Robertson here at NC State, and he just had his a PhD student finish up working on this kind of project, Josh Run. So we're really excited to see the outputs that come from that. Now, if we look kind of in-season assessment, mid-season, there's always, we can always fall back to the UAV tools, as that's becoming more and more popular. But, what we don't have are a real consistent set of tool sets across all of the cotton-producing states to look at what can we detect early in the season that go along with our official variety trial programs to compare not just yield, but are there other factors that we can start assessing about those varieties or hybrids that are being introduced into these official variety trials. So what can we detect remotely? What are the right tools? So we're working a lot to try to create those kind of protocols that work very well across states with my colleagues all across the cotton belt. Now, if we look late season harvest, cotton's an interesting environment. There's a few different machine types. There's stripper cotton, there's picker cotton. Although it kind of looks like Deere's kind of led the way so far with this wrapper picker. That you see so much out there now with the yellow wrap or the pink wrapped cotton modules. But they still are doing a lot of processing of that data. They're collecting yields you can get from this cotton harvest. But one of the things we're looking to do is to kind of bridge the gap between the field and the gin. And so after cotton is harvested, it gets wrapped, the module gets made in the field, and then it gets transported to the gin. And the gin is where seed cotton is converted into a bale of cotton that is seed-free. That's clean fiber that's then baled up before it goes to whatever kind of end user it's going to. So and each one of those bales gets sampled for quality. So we can look at fiber quality, things like the diameter of that cotton fiber, the length, the uniformity of the length. And all those things are important to the buyers who those properties affect during the spinning process and weaving process, the quality of that shirt or sheets or whatever it is that's being made from that cotton down the road. So what we're actually trying to do now is to collect that fiber quality data and track that bale all the way back through the ginning process, through the gin yard, all the way back to the field, to a specific piece of ground. Say this bale came from this point, and these were the fiber qualities that came from this area. And now we can try to make decisions about what can we manage to improve fiber quality throughout the entire growing season. So we're pretty excited about the fiber quality maps. I think I had some colleagues in Australia beat me on getting a fiber quality map made first. Hey, good for them. I'm glad they got out there. But I think we'll be some of the first in the U.S. to get this map kind of all the way through the process. It's a lot of data wrangling and trying to identify the gaps between how a machine generates data versus the gin generates data and how we collect it all and analyze.
It's obvious that harvest is really kind of a key focus when it comes to the precision agriculture as far as cotton goes. And there are a lot of opportunities, it sounds like, in the other instances. So planting and the replant decisions and what you're doing there, there's a lot of things that can be added or changed down the road. Aside from the fiber quality mapping, is there anything else new and exciting that's kind of coming down the pipeline that you could share with us?
Yeah, absolutely. There seems to be a lot of interest in what can we do at harvest with, imagine this, robotics. Okay, so cotton fiber and cotton yield is all very determined by what position on the plant that the cotton boll came from. And so if we can rethink harvest to now include a handful of small robots that go through a field, they can selectively harvest the cotton bolls that are most mature and at the right timing to be able to pull the best fiber quality out of that field. So the idea of moving from a single pass large harvester to a series of distributed robots moving across the field selectively harvesting those cotton bolls is a really exciting new initiative that some of my colleagues across the university, other universities and at Cotton Incorporated are really working on.
I know robotics is a huge push when it comes to the autonomous tractor, or it's really cool to hear about the robotics as far as cotton goes. And I had no idea that cotton, the quality of cotton and the fiber quality and whatnot, it all has to do with that plant, and it kind of comes down to your typical agronomics of corn and soybeans. Everything it happens in cotton too. So it's neat to hear about the robotics and how it can be utilized. When we talk about all of the precision ag, the mindset, the practice, the hardware, how is this stuff going to be utilized in cotton, whether it's the grower using some of this stuff or it's the information that's capable of being viewed by the gin? When we think big picture, what do these technologies and data look like in the cotton industry?
Yeah, I think what's really interesting is that we're really kind of meeting the promise of what the technology was there to do. Right, we've seen this happen in precision ag before, where we saw in the kind of the first runs of it, yield mapping or all these other tools were first coming online. A lot of people got excited, and then there's this gap as people realize it's a little bit harder than what we thought it would be, right? And now I feel like we're settling into this place where we're actually meeting the promise of what precision ag was originally envisioned to do. And I think if we look across the board, the enabling technologies are the machinery data and the CAN bus and those kinds of systems that allow us to get that machine data. And then ubiquitous or semi-ubiquitous, and in my area, cellular data coverage, so we can move data off of these machines in near real time and collect it in a way that can be utilized very quickly. I also think creating these tools, whether these are cloud-based or local machine-based tools, that allow us to get access to this data quicker and process it and push through to the meaningful relationships behind it. But absolutely, if you look at a production system as integrated as cotton is, all the way from seed through growing and then harvest, and have it all go to the gin, and the gin then being a whole nother layer of data that goes on. It's very similar to some of the other markets, perhaps like some of the vegetable markets where a shipper packer plays an important role in the value chain. But that last data gap really happens at the gin. And I know there's been incredible work in the software that run these gins now. And what's amazing to me, a modern cotton gin is so much. There's so much material that goes through it. It's really amazing how clean and safe it really is, and how they're taking this raw cotton and they're creating a clean product that's ready to go into manufacturing. But closing that gap between the field and the end use really happens at the gin. And right now, it can be a manual process. It can be somebody writing down a serial number on a module that's going in and then tying it to a bale identifier tag. And so it can be very manual. But creating the right tools that can read the RFID tags of the modules as they're coming in and create the right data pipeline to connect that to the bales, that's what's really going to close the gap for us to get this full identity preservation solution going on, so we can know this bale that was used to make these products came from this field. And that's what really gets me excited.
Just hearing you talk about the tremendous opportunity that there is in the cotton production world of agriculture is just really exciting to hear. It, like we had talked earlier, we've always thought about precision agriculture, one, as a hardware or a component standpoint, when again, you guys are looking at it from more of a practice standpoint, and you think precision agriculture and you always think corn and soybeans, but there's so much more to it when we start looking at these specialty crops and everything that you guys are doing down there at North Carolina State. It's really cool to hear the different things, the way to look at things, and what you can do. And is there any sort of, with all of the research you've done, Jason, and the research studies that you're doing, is there any sort of a success story you'd like to share with our listeners about any of it?
Absolutely, but my success story sounds a little bit more like a failure when you first hear it. Okay. So I was working with some of our local peanut producers, looking at field efficiencies at planting. And so, peanuts require a little bit of soft hands. So you see some producers using some older style planters, not a whole lot of electric drive in that market right now, kind of ground drive systems. And this particular producer was planted 800 acres with a 6-row planter. And we were just looking, we tapped into their CAN bus to monitor their machine performance and how long it took them to do that job, and look at their field efficiencies with that particular equipment complement. And I looked at what I thought were some idle points in the field, and realized that it looks like they've been coming back to this one single point over and over, getting to refill, and that seems like there should be an easier way to do that. And so I started, talking about this data and this outcome, and then I presented it, and I was telling the story and what I thought had happened here in this field. And then a producer says, "Yeah, that's one of my fields, and that's not what we do at all."
Wow.
So I started. So he was very kind. He definitely could have raked me over the coals, but I think that what my success story there was to always make sure that we keep the data in the context for what that local producer is doing, because it's very easy for us to think, well, we've got all the data, and we can see and get all this insight and make all these decisions. But I think that we have to always remember and always be very aware that this happens within this larger context of ag production, and there's reasons why certain things happen a certain way. And if we don't listen first before we start trying to talk about all this whiz-bang insight we can gather, then we kind of wind up making conclusions that maybe don't reflect reality.
I couldn't agree more when it comes to the in context, out of context. If we start looking at things out of context, it gets really messy in a quick hurry. So that is a really cool success story to hear how you perceived it and how it was looked at. If anybody wants to learn more about what you're doing at NC State, or maybe they're curious about some of the cotton production stuff, where can they go and who can they talk to learn more?
So I'm at NC State University. My lab and my team, we're called the Advanced Ag Lab. You can definitely look us up on the Biological and Agricultural Engineering website at NC State University. I would always point you towards Cotton Incorporated. They've been a sponsor of my work and are a producer-driven organization that really supports research and extension work on all through the value cycle of cotton. So there's a huge number of resources via Cotton Incorporated that the producers can go to, and anybody's interested about cotton production. Cotton Incorporated and their suite of sites really does a great job. We're also in the process of standing up an extension portal. So I have part of my job is extension. And so I work with a lot of other great extension people across a range of commodities and technologies. And so we're in the process of standing up what's called the Digital Ag Portal at NC State University. And you'll be able to find that here when it gets launched within the next couple of weeks at Digital Ag, all one word, .ces www.ncsu.edu. Of course, you can find me on Twitter at JK Ward.
Wonderful, Jason. I just want to thank you for sitting down with us today and talking about your perception of precision agriculture, and then also filling us in on so much of the information when it comes to cotton and the great opportunity that is out there. So thanks again for doing this.
My pleasure. Thank you so much for the chance to talk about a crop that I think is really important and I really enjoy working with.
Thanks again for listening. Subscribe to this YouTube channel for upcoming podcasts or visit rdoequipment.com/podcast to listen to new episodes and catch up on any that you've missed. You can also listen and subscribe to our podcast on any device or streaming service so that you will never miss out on the latest news and technology from RDO Equipment and John Deere.